Hello everyone, I am Maaiz Shaikh. I am second year student pursuing my BTech degree in Computer Engineering branch from Pandit Dayal Energy University. I am from Division 3, Group 5, Team 4. Our team has developed an Android app as a part of our operating system lab project under the guidance of Dr. Ruthviz Zaveri. We have used Android Studio as IDE and Java as programming language to build our app. Our app name is Deadlock and Concurrency, which is based on, as name suggests, theory of deadlock and concurrency and few algorithms to prevent deadlock and synchronize processes. So on behalf of my team, I will take you through our app and its various functionalities. So let's get started. So this is our app logo with our app name, Deadlock and Concurrency. When I click on it, it will show first splash screen. So this is our home page, and when we click on start button, it will show us index page. So we need to pick out of these three options, that is concurrency, deadlock and algorithms. When I click on concurrency, it will throw me to the page of concurrency. So here we have written all the necessary theories in brief regarding concurrency. Let's go back. Similarly, when I click on deadlock button, it will throw me to deadlock page with all the necessary theory of deadlock in brief. Now let's go to algorithms page. So this is our algorithms page. So let's have a look on each and every algorithm one by one. First is Peterson's algorithm. So this algorithm is basically used to synchronize two processes. Let's have a simulation. Okay, so we have two processes, P0 and P1. And when we click on any one of this process first, it will enter into critical section and won't allow other process to enter until and unless it finishes its activity. So let's check it. If I click on P0, it will enter into critical section and it won't allow P1 to enter into critical section. See, turn variable is 0. That means it is turn of 0th process or P0 process, or P0 process is entered in critical section. So P1 can't be able to enter into critical section. Let's finish process P0 activity. Now P1 will easily be able to enter into critical section. Now let's refresh it and repeat the same example with P1 process. So let's click on P1 process. It entered into critical section and P0 process won't be able to enter into critical section. See, turn variable is 1, which means its turn of P1 process or P1 process is in critical section. So it won't allow P0 to enter into critical section. Now let's finish P1 process. So now P0 process will easily be able to enter into critical section. Okay, so that's it for Peterson's algorithm. Now let's move on to Banker's algorithm. So Banker's algorithm is also known as deadlock avoidance algorithm. Basically, it helps us in stating whether process with allocated resources and maximum resources will cause deadlock or not. If it causes, then it will display unsafe. Otherwise, it will display safe with safe sequence of processes. So let's have a simulation. Okay, here it is written enter number of processes. So I will write 5 and then 3 number of resources. The number of process 5 and number of resources 3. Now here we need to enter available resources with space separated values. So I will write 3 space 3 space 2. Similarly here we need to type space separated values for allocated resources for each and every process. So let's enter the value 0 space 1 space 0 at for P0, for P1 2 space 0 space 0. Now for P2 3 space 0 space 2, for P3 2 space 1 space 1, and for P4 0 space 0 space 2. Now if you want to add for one extra process, it won't allow you to add that value. See, 2 space 5 space 6, I am writing this random value, so can't add more values. Alright, now let's enter the maximum resources for each and every processes. 7 space 5 space 3 for P0, 3 space 2 space 2 for P1, 9 space 0 space 2 for P2, 2 space 2 space 2 for P3, and 4 space 3, okay, 4 space 3 space 3 for P4. Similarly, if we want to add maximum resources for extra processes, it won't allow us to do so. See, 5 space 6 space 3, can't add more values. Now let's click on next. So the input values that we have entered result in safe state, means if we enter these values, then there will not be any deadlock, and this is the safe sequence for process to execute P1 P3 P4 P0 P2. Okay, now let's move on to next, producer consumer problem. So it is very basic classical problem based on synchronization. Let's have a simulation. So if I entered buffer size at 6 or maybe 5 and produce 2 items at a time and consume 1 item at a time, then see, buffer size is 5. If I can produce, then it will produce 2 items consume, then P0 is consumed, P1 is consumed, P2 is consumed, P3 is consumed. Now if I will consume, it will show buffer is empty. Now it will produce P4 P5 P6 P7, so 1 2 3 4. Our buffer size is of 5. So if I produce once more, it will produce P7 and it will say buffer is full. Okay, now let's see the last dining philosopher problem. Let's directly jump into simulate button. Okay, so these are our 5 philosophers. All 5s are on thinking zone or thinking mode, and let's say P0 is hungry, P1 is hungry, and P2 is hungry. Now if P1 is given chance to do eating, then P0 and P2 won't be able to eat because for is allocated to P1, but P3 will easily be able to go to eating zone because both the forks from P2 and P4 are free for P3 to do eating. Now if I will put P1 in thinking zone again, then P2 won't be able to do eating because one fork is with P3 philosopher, but P0 philosopher will able to eat. Now let's finish P3 philosopher eating and let's send P2 philosopher to do eating. So see, in this way it works. Okay, so that's all for algorithms. Now let's see navigation bar. So we have two options in our navigation bar: about app and about developers. In about app section we have all the details that why you should use this app, and in order to gain more out of this app, how you should use this app. And last section is about developer section. Here this is the list of all the developers who has contributed in order to build this app, and when you click on any one of the developers, it will throw you to that LinkedIn ID of that developer. So see, if I click on my, it will show my LinkedIn ID. If you click on Kris, and it will show his LinkedIn ID. Alright, so now that's it from my side. Thank you very much.